Okay, class, we're about to start on section 5.3, multiplying decimals. Section A, multiplying decimals. Suppose you wanted to multiply the decimals 2.1 and 3.82. Before you even begin to multiply, can you estimate what the answer would be? Let's round to the nearest ones place. So 2.1 will actually become 2. 3.82 will become 4. 2 times 4 is 8. Okay, now let's try the actual numbers. It says now let's do the multiplication. Multiply as if they were whole numbers, like 21 times 382, and don't worry about the decimal points for now. Since 382 is longer than 21, I'm going to list 382 first and then multiply that by 21. Now again, we're not including the decimals here. So 1 times 2 is 2. 1 times 8 is 8, and 1 times 3 is 3. Now we put our 0 here as a placeholder. 2 times 2 is 4. 2 times 8 is 16. Carry a 1. 2 times 3 is 6, plus 1 is 7. Now we add them together. 2 plus 0 is 2. 8 plus 4 is 12. We carry our 1. 6 plus 3 is 9, plus 1 is 10. Carry our 1. 7 plus 1 is 8. And now we go through this process. Now we multiplied these values. Now we have to place our decimal point. So we go back up to the two original numbers. You look at the amount of numbers, the total amount of numbers you have behind the decimal here. You have one number here, and then we have two more here. So 1 plus 2 is 3. So that means our final answer must have 3 digits behind the decimal. So if you look at this problem here, you could do regular multiplication without the decimals. The multiplication doesn't change. But at the end, you must count how many numbers you had behind the decimal, the total amount that you had behind the decimal, and that's how many you're supposed to have behind the decimal for your final answer. And since we have 1, 2, 3 here, that means we must have 3 behind this decimal. Now we come to this question. Based on your estimate of the answer to this problem, where do you think the decimal point should go in the final answer? We already put that earlier. So it was basically, let me scroll back up, it was 8.022. And that is close to your estimate because our estimate was 8. Now we come here. The rule for multiplying decimals is, number 1, multiply the decimals as though they are whole numbers. Number 2, the decimal point in the product is placed so that the number of decimal places is equal to the blank of the number of decimal places in the factors. Okay, now let's read that again. The decimal point in the product is placed so that the number of decimal places is equal to the blank of the number of decimal places in the factors. The sum of the number of decimal places in the factors. Remember, it was 1 in the first problem. We can go up here. 1 in the first factor. And it was 2 in the second factor behind the decimal. So it was 1 here and 2 here. And we took their sum, and that gave us 3. So that's why we had 3 digits behind the decimal. Now, it says here, but don't forget that your answer should make sense in terms of an estimate. Now, as far as these problems, for the sake of time, I'm not going to do the estimates. We're just going to go straight into the multiplication. So again, like we did in the previous problem, let's imagine that these decimals are not here. So this would be 64 times 37. 7 times 4 is 28. We carry our 2. 7 times 6 is 42. Plus 2 is 44. We add a 0 here. 3 times 4 is 12. You carry your 1. 3 times 6 is 18. Plus 1 is 19. Now we add them together. We have 8, 6. This is 13. You carry your 1. And this is 2,368. But remember, we go and count how many digits we have behind the decimal in each of these factors. and we take its sum. So we have one digit here, one digit here. 1 plus 1 is 2. So our final answer must have 2 digits behind the decimal. Now we go to problem number 2. If we imagine the decimal is not there, this 7.91 will be longer than this 6. So we'll put 791 on the top times 6. 6 times 1 is 6. 6 times 9 is 54. We carry our 5. 6 times 7 is 42 plus 5 is 47. So we have 4,746. Now we count how many digits we have behind the decimal. We had 3 digits behind the decimal, so our final answer must have 3 digits behind the decimal. Now, we go to this next problem. Now, multiplying by positive and negative numbers still results in the same. A negative times a positive is negative. So we know our final answer is going to be negative. So we could disregard the negative sign until we get to the final, our final answer. So here we drop this decimal. We'll take 12 times 34. 4 times 2 is 8. 4 times 1 is 4. Bring down our 0. 3 times 2 is 6, and 3 times 1 is 3. Now we add them. We have 8, 6 plus 4 is 10. We carry our 1. 3 plus 1 is 4. Now, before we do our decimal, remember our answer must be negative. So let's put our negative sign there. Now, if we look here, we only have 1 digit behind the decimal. So our final answer will have 1 digit behind the decimal. Now, we have 0.9 times 0.6. We drop those decimals. We have 9 times 6. And we know 9 times 6 is 54. Now we count how many digits we have behind the decimal. We had 2 digits behind the decimal. So we need 2 digits behind the decimal here. So the decimal will go here in front of the 5. But just for mathematical purposes, to make it look correct, we need to have a digit in front of the decimal. So it would be 0.54. Now, we go down here to number 5. We have 0.2 times 0.4. So this is the same as 2 times 4. 2 times 4 is 8. Now if you notice here, we have, when we add up how many digits we have behind the decimal for the 2 factors, we actually had 2 digits. But we only have 1 digit here. So what we will have to do is add a 0 in front of this digit in order to give us the amount that we need behind the decimal. So now we put our decimal here, and we put a digit in front of the decimal. So we have 0.08. Remember, when you do not have enough digits in your answer, you must put the zeros in front of the number, not behind. Okay, number 6. Now, first of all, let's look at this. Negative times a negative, we know it's positive. So we don't have to deal with the negative signs anymore. So we drop this decimal. That will give us 31 times 18. 8 times 1 is 8. 8 times 3 is 24. Put a 0 here. 1 times 1 is 1. And 1 times 3 is 3. Now we add them. We have 8. This will be 5. And this will be 5. So 8 plus 0 is 8. 4 plus 1 is 5. And 2 plus 3 is 5. Now we count how many digits we have behind the decimal. We have 3 here. We have 2 here. So that's a total of 5. We only had 3 digits here. So we have to add 2 zeros in front, put our decimal, and a 0 in front of the decimal. And that is our final answer. Now we come to objective B, multiplying decimals by powers of 10. Look for a pattern in the following products. Now when we say powers of 10, we're talking about 10, 100, 1,000, 10,000, and so on, not 10, 20, 30, 40, 50. So it's 10, then 100, 1,000, 10,000, and so on. So whenever you multiply a decimal by this multiple by powers of 10, what you do is look how many zeros you have in that power of 10. You have 1. So what that means is you will move this decimal to the right 1 place. And that will be your answer. So it'll be 54.83. We have 2 zeros here. So this decimal will move 2 places to the right. So it'll be 1, 2. So this would give you 548.3. We add 3 zeros here, so that means that decimal would move 3 places to the right. So it'd be 5,483. Now we have 4 zeros here. Now we will have to move this decimal 4 places to the right. Now if you notice, when we move it 3 places, that covers all the numbers. But we have a 4th place we have to move it. So we fill that place with a 0. So it'd be 54,830. Now we do the same thing for 5 places. With the 5 places, you know we will have 2 extra places that we move that decimal. So our final answer would be 548,300. Okay, now we scroll down here. We have multiplying decimals by powers of 10, such as 10, 100, 1,000, 10,000. Move the decimal point to the right, the same number of places as there are blank in the power of 10, and that would be zeros. Okay, now it says look for a pattern in the following products. Now, for the sake of time, I'm just going to tell you this. These are still considered to be powers of 10. They're just going in the opposite direction behind the decimal. So when we multiply this, we count how many digits we have behind the decimal, which happens to be here. We have 1 digit behind the decimal. So that means we move this value to the left that many places. So it'll be 2.36. Now remember, this 1 here is a power of 10 because this is really 1/10. Isn't this 1 100th, 1 1,000th, and 1 10,000th? So these are powers of 10. So this is what we do here, the next problem. We add 2 digits behind the decimal. So we have to move this decimal 2 places. We don't move this decimal 2 places to the right. We move this decimal place 2 places to the left. So it'll be 0.236. Now we come down here. We add 3 digits behind the decimal. So we move this decimal to the left 3 places. Now if you notice, we don't have anything for this 3rd place. So we replace that 3rd place with a 0. So it'd be 0.236 and a decimal in front of it. And actually we need to put a 0 in front of that. Now it's 4 places. Just like in the last problem. We move this time 4 places. That's 2, 3, 4. So we have 2 zeros, 236, and a decimal in front of those 2 zeros, and we add another 0. And that is our answer. Okay, now we have this definition. Multiplying decimals by powers of 10, such as 0.1, 0.01, and so on. Move the decimal point to the left, the same number of places as there are digits behind the decimal. It's digits behind the decimal in the power of 10. Now that is how we would do those problems. Now we have 2 examples here. We want to multiply. We have 0.852 times 100. This is multiplied by 100, so we move this 2 places to the right, and it'll be 85.2. Now we have 7.6 times 0.001. Now we add 3 digits behind the decimal, so we move this decimal to the left 3 places. So we will have 2 zeros, 76, a decimal in front of that 0, and another 0. And we're done. Okay, next we have problem number 3. 94 times 0.1. We have 1 digit behind the decimal. That means we move this decimal 1 place to the left. Now 94 is assumed to have a decimal at the end, like I told you in an earlier problem. And we move that decimal 1 place to the left, which will give us 9.4. Now this problem here, 8.4 times 10,000, We have 4 zeros here, so we have to move that decimal 4 places to the right.